with an integral. The integral, it can be integral of sine. Maybe it can be 3x dx. So when I have this one, I know that my integral of sine of x dx equals to negative cos x plus c. So now when I know that, but here now we have 3x. So that's when also I'm gonna use a substitution. I will let my u equals to 3x. So when I let u equals to 3x, then my du is going to be equals to 3 dx. So when it's 3 dx, I can divide by 3. Then this will imply that my 1 over 3 du is going to be equals to dx. So now when I have that, I can substitute now. What is my u? My u is 3x, which means I'm going to say sine. Where there is 3x, I'm going to put u. Sine u. Where there is dx, my dx is 1 over 3. 1 over 3 du. So this is going to be equals to 1 over 3 integral of sine u du. So now, if by born dori u equals to 3x, where there is 3x here, I substitute. I didn't substitute in all sine x. I only put where there is 3x u. Then after that, I substituted where there is dx, because we know that dx equals to 1 over 3 du. I substituted with 1 over 3 du. Then I take out 1 over 3 in outside of the integral. Then we're gonna left with 1 over 3 integral of u du, which is the same as 1 over 3. Integral of sine u is the same as this one, which we can just say is negative cos of u. We can also say plus constant. So now what I can do, I can just substitute back. When I substitute back, this is going to be negative 1 over 3 cos of what? Cos of our u, we know that is 3x, cos of 3x plus c. So that's how simple we can work them out. So if we check also in our, the same way, it applies when we are using cos x or cos theta. So if we check it, in this scenario, let's say, for example, we're gonna take, let me first, this is the integral by substitution. We're gonna take, this one is the one that we just did now. So what about if we are working an integral of, let's say, sine squared x? Let's try to work out sine squared x. So in the integral of sine squared x, we have an integral of sine squared x. So sine squared x dx. What we can see here, we can see that, okay, here we have our sine squared x. Even if we rewrite it, sometimes when you try to apply, when you try to answer this question, firstly, try to check what you can do. Sometimes normally I used to write sine x first, or I say sine x like this way. I will put squared, the brackets. So when I put squared dx, I will check on normal. Even if I let my sine x equals to, if I let, let's say u equals to sine x, when I differentiate it, it's going to get cos, and we don't have cos there. So what exactly can we do? So some of the times when I have this one, I will change my integral of sine x, sine squared x, because I know that according to the identity, I have an identity which says sine squared x plus cos squared x equals to 1. So which means my sine squared x equals to, can be 1 minus cos squared x. So what can happen if I change this sine squared x to be 1 minus cos squared x? Is it still going to be in a form that I'm gonna be happy? Okay, I can try to put it 1 minus cos squared x squared x dx. But the problem part still applies that here in 1 minus cos squared x dx. Cos squared x, it is still going to be the same as the way we know it. And the other thing, we know about cos squared x. Cos squared x, we also know that cos squared x is going to be 1 minus sine squared x. But we also have identity whereby if we have cos of a, cos a plus b is equals to cos squared, or cos 2a, cos squared, let me say cos 2x. We know that is the same as cos squared x minus sine squared x. So which means now, if I have cos 2x, I can change my cos 2x. I can change this one to come the other side. Then my cos 2x minus sine squared x is going to be equals to cos squared x. So if I change that, I can write it as cos squared cos 2x plus sine squared x, which is equals to cos squared x. So, but even if I do that, am I going to still achieve the results in a simple way when I'm using this way? Am I still going to achieve what I want? So we'll find that even if I put where there is cos squared x, I put this, it's still going to have a sine squared x, which I'm still having a problem with it. So that's when now we're gonna need to work out exactly what should we do. So that's the problem that we're gonna be working with in order for us to achieve this sine squared x. So that's the that's where the problem is, in order for us to know what must we do in order for us to know to work it out. So what do you think you can do when you see it? We have tried to check all the method, and then all the method, they are looking so complicated to solve them.
But using that first identity, can't we let u is equals to cos squared x?
Let u equals to?
Cos squared x.
Cos squared, let u equals to cos squared.
Using that identity, that's there.
This one.
Yeah.
Okay. If we let u equals to, we let u equals to what?
Cos squared x.
U equals to cos squared x, okay?
Can't we differentiate it like that?
So if we differentiate this one, our du is going to be equals to what? 2 cos x dot negative sine of x dx, in which is going to give us negative 2 cos of x sine of x dx. And the problem part now, if we differentiate in this form, we don't have sine x here. That's the problem. It's a good starter, but the problem part is that we do not have sine x. So we have to find a way in such a way that when we differentiate it, it must not give us that problem. It's a good starter, it's true, but the problem part is that we do not have that sine squared x. We don't have sine squared x.
Okay.
So that's the reason why we need to find that identity.
Okay.
So according to, there is an identity. When you're working it out, I'm gonna try to solve it for you. We have identities. The first identity that you must know is that sine squared x equals to 1 over 2, 1 minus cos 2x. Did you know about this identity? So there are two of them. Even for cos squared x, So for sine squared x is 1/2 minus cos 2x. And then for cos squared x, sine squared x, these are the identity from high, like from high school.
Okay.
Yes, so you can try to prove it, you're gonna get exactly this. So if we prove it, let me try to prove it. 1/2 is 1 minus, we know cos squared 2x is going to be cos squared x. I'm gonna put brackets here, minus sine squared x, ne? Sine squared x. So this is going to be equals to 1/2 in brackets 1 minus cos squared x plus sine squared x. So if we multiply everything by 2, 1/2, we're gonna have 1/2 minus 1/2 cos squared x plus 1/2 sine squared x. So normally if we take this one here, even if we take, you will see that cos squared x plus 1/2 cos squared x plus 1/2 sine squared x is going to give us 1/2. We know that is going to give us, even if we take out the negative minus 1/2, you will see that this will give us what? It's going to give us 1, né? Then we're gonna be left with 1/2 minus 1/2, which is going to be equals to 0. So do you see that is indeed sine squared equals to that?
Yes.
So that's how it is. So now when we work with this type of integral, if it's sine squared, when you check, you must put all the identity that you know, then which means when I work it out, I'm going to use a sine squared x dx is going to be equals to integral of 1/2 in brackets 1 minus cos 2x dx. So now at least you know what is sine squared x. Then I can take 1/2 outside. I'm gonna be left with integral of 1 minus cos 2x dx. Then this will mean that I can write this as 1/2. Inside my integral, I will have integral of dx minus integral of cos 2x dx, which this is going to give us 1/2. 1 is going to be x here, minus integral of cos 2x. We can let u equals to 2x, but normally we know the answer is going to be 1/2. Normally, when you get to work this kind of integral, we must know that the answer here, when we work it out, we don't really have to do this method anymore. We just have to work it out, because the more you are working with this kind of integral, you won't need to, let's say, a substitute. You will just have to know that when you see this integral, it's going to be what? In brackets, 1/2 sine what? Because we know that when integrate cos is positive, it's going to be sine 2x. Then you can say plus what? Plus c outside. Then which this is going to give us 1/2 x minus 1/4 multiplied by this sine 1/4 sine of 2x plus constant, which is c. So this is how we do it. So the only trick with this one was to know how to write it down in this format, knowing the form of sine squared x equals to 1/2 in brackets 1 minus cos 2x. So which means if I have an integral of cos squared x dx. Then if I have to work it out, the first thing that I can do, I can change it to become 1 minus sine, if you only know that one, sine squared x dx. And when I change it to this way, I will have integral of dx minus an integral of sine squared x dx. Then I know that my integral here of x is going to be what? It's going to be 1, not 1, it's going to be x minus the integral of sine x dx. We can just copy this, is minus, which is going to be 1 over 2 x minus 1 over 4 sine of 2x. Then we can say plus c. Then the final answer will be x minus 1 over 2 x plus 1 over 4 sine of 2x plus c. So which means my integral of cos squared x is going to be these results. So we have worked it out using the method, or if you want to first substitute, you can first substitute for sine x squared. You can first substitute 1 over 2 in the integral. 1 minus what? Cos 2x. Then you work it out. So this is how we work them out. So if we check here in our document, you will see that we have cos squared, this one. So the cos squared there, let's try to check if it's solved. Okay, we can ignore the upper and the lower 0 and pi, but we'll see that cos 2x equals to 1 minus sine squared x, cos 2a. And the reason part here, they wrote some of the identities. Cos 2a equals to that, cos squared x minus that, but cos squared x, then you can see, which is equals to 2a, 2 cos squared x minus 1. They try to write all those identities, the 1 tan x, you have to know them. Then when you take it, you will see that exactly 1 over 2x minus 1 over sine x. This is exactly what we get. This one is just the definite integral. So that's how it works. So if we have an integral of, let's say, for example, the other one, we are working with integral of sine is cos 3x sine 2x dx. Let me see if I've copied it right. Yes, sine 3x cos 2x sine 3x cos 2x. So now we have this kind of integral. So if we have this kind of integral, which is cos 2x, how can you solve it? Now we know that if we can let u, if we can let one of this integral to be u equals to cos something, then we're going to have sine something. We're going to have what? We are going to have cos. All right, so let's go back. So now this integral, if we check something, the problem part is that even if we let u, if we can let our u equals to cos 2x, our du is going to be equals to negative sine 2x dot, we differentiate this, we're going to have 2, which we can rewrite it as negative 2 sine 2x. But the problem dx, but the problem, our sine x here, our sine x is not the same as 2x, it's 3x. So that's when we have to think of what can we do in order to get something better than this. So in this question, I can decide to start with sine of 3x. When I say sine 3x, I can write sine 3x as sine of 2x plus x. And if I write sine of 2x and plus x like this way, which means I can rewrite this as sine 2x dot cos sine 2x dot cos x plus cos of 2x dot sine x. So if you see sine 2x cos x dot cos plus cos 2x sine x, so we cannot make them to be together because here sine 2x it have 2 and cos it have 2x. So we needed something that it can be exactly in the same format to be the same. So now when I have this, I can now substitute it back to my equation here in this equation. So if I substitute back in this equation, the formula, the other thing that we may need to take into account before even we take a very long step, what is sine 2x? Sine 2x equals to cos 2 sine x sine 2x equals to 2 sine x dot cos x. So now we have sine x dot cos x. So now here, if we check the relationship between this one and these two, the way it is here and the ones we have there, we will see that we don't have that kind of relationship. Then if you are a person who don't want to maybe you want to go the long way, the only thing that we can do, we can substitute back to this equation. Everything that we just did now, we can just substitute back to sine 3x. So when we substitute back to sine 3x, it means that now our integral that we're going to work is going to be for cos 2x in brackets, where there is sine 3x, we write sine 2x cos x plus cos 2x sine x dx. So if we check this one, we will understand that we can break this integral to be an integral of cos 2x sine 2x cos x dx plus an integral of cos 2x into cos 2x dot sine of x dx. So now we can rewrite it as integral of, maybe we can just change it to be cos 2x. We are not changing it anything. We are just rewriting 2x and cos x dx. So plus this integral is going to be cos squared 2x sine x dx. So if we check here in this integral, we have things in common. We know that sine 2x equals to cos x plus cos x sine x. So when we know that, which means 1 over 2 sine of 2x is going to be equals to sine of x cos x. I just divided this equation by 1/2. Then now when we know that that is equals to that, what can we do? What if we change, we put 2x here? Which means we can allow that 1/2 sine of 4x is going to be equals to, do you believe that it will be equals to sine? It won't be sine 2x. It won't be exactly, it won't be sine 2x plus dot cos 2x if we put 1/2 there in this equation, because 1 cos 1/2 plus sine 1/2 is going to give us sine 2x plus 2x in such a way that this is going to give us not exactly 2x there, 2x. So it's going to give us this maybe 2 times, which I'm not going to prove now. It's going to take much time. So now we have tried to reduce them. So if now we have this, what can we do in order for us to have the one equation? We have worked it out properly. So what do you think we should do now? We can still change one thing to be better. If we change one thing here, the only thing that we can change, if we change sine 2x, if we change cos squared x, we're going to have sine cos squared x. If we change sine 2x is going to give us 1/2 cos x sine x, which we can write it here, sine 2x, we can make it, if we change it, that integral can come in a form of cos 2x, 1/2 outside, and then cos squared x sine x, but dx. So if we change that to be cos squared x sine x dx, we have cos 2x also. Cos 2x, we know that is cos squared x minus sine squared x. So if we change that to that, it can still work somehow. Then which means if it's working, this one, it can be more simpler. Then we can rechange it back. 1/2 integral of, it's gonna say cos squared, which we can write it as cos to the power 4 x sine x minus sine cubic cos squared x, everything dx. We are just taking this part, only this part. So after writing this, we can separate them. We can have an integral of 1/2 integral of cos to the power 4x sine x minus 1/2 integral of sine cubic x cos squared x dx. And now the other part of the first part here, if you check this part here, we can work it out by letting u equals to cos squared x. Then your du is going to be equals to negative sine x dx, which is going to imply that our negative du which can implies that our negative du is going to be equals to sine x dx. And we have sine x dx. Sine x dx is here, just that we have to write dx there, I forgot. Sine x dx is there, then which means you can substitute. Then we go back to this part here. This one here, we have cos squared cubic, sine squared cubic. What happens if we can take our u to be one of these, or do we have to, for cos squared, to change it back one of these? We know that we can change cos squared cubic to become 1 minus sine squared x. So if we change it, is it going to work for us? That's the question. Or must we change maybe one of these to be cos squared? So when you work it out, we have already, for this part here, if you check, we're already done with this part because I already substituted. So for sine squared cubic, for this one here, I can change. I know that I can write my sine squared sine x like this way, dot cos squared x. So I can change it to be in the form of, I will have 1 minus cos squared x dot what dot sine x cos squared x. So that I can have cos squared x sine x minus cos to the power 4x sine x. So if you see now, this one, it can be changeable properly because I can let you now, I will have x dx. I will have sine x. I can let you also this side, I will also have what? Sine x. So this one, it's, if you are working it properly with just a step-by-step of integral, it will take long, but you're gonna get straight to the question. So I want you to try to finish it so that you can see what's happening. Then you only use this method that I'm doing there. So it's gonna help so that you can understand also the other integral. So this part here, this other one, now I'm done with that one. So this part here, cos squared 2x and sine x. We have cos squared 2x sine x, whereby now if I can let my u, if I let my u equals to 2x, my du is going to be 1 over 2 du dx. But now when it's like that, my du here, I'm going to let u equals to that. But I have sine x here. What can I do? Because there is a sine x, but here is just cos squared 2x. And we also know that sine squared x, sine, okay, I don't want to erase here. We also know that sine squared x equals to 1 over 2, 1 minus cos 2x. Then now our cos 2x here, cos squared 2x, what can we do in order to get cos squared 2x? We can multiply by 2. We take, is gonna be 2 sine squared x. Then we take this one, the other side is gonna be minus, which we multiply by negative is gonna be 1 minus 2 sine squared x equals to cos squared 2x. So cos squared 2x, cos 2x going to be equals to 1 minus 2 sine squared x. If we square both sides here, we square, even this side we square. Then which means cos squared 2x equals to 1 minus 2 sine squared 2x to the power 2. Which you can also use it there. When we use it, which means here you have to expand. So this one is kind of like a long one, but it's not really long, just that I'm making it to be long.
And the length is more confusing me.
My mathematics, oh, okay. Now this one is more nice when you are working it relaxed so that you can see. The moment when you are working the way I'm doing, you will end up learning the point of this one, why I'm doing it this way. You will end up learning about more of the identities. There are many identities that you will come across when you are doing it this way. You are going to come across that cos squared 2x squared equals to 1 over 1 minus sine 4x over 2. So those are the things that when you work it out like this way, you are going to come across those identities. So it will come like it's without the name, but the one in which bapa 4 sine x, but then you can detect it. That's why I'm doing it this way. There is also a very simple way, but the simple way, it won't make you to understand the integration. So which means the way we are doing it now, it will help you to, so that if there is another integration which can be more difficult or more like maybe it's a new integral, so you will be able to tackle it without even knowing all the identities, just applying the simple mathematics.
Okay.
So that's why I'm not gonna complete. It's already complete, just that I also want you to do it and learn, try to do it. It can take you 3 pages or 5 pages, it's fine. But at least you're gonna have, you will see something, the relationship, what is happening.
Okay.
It's very simple one. There is nothing much. There is just that I just want you to see something. So which means this one you have to finish it.
Okay.
Then you can send it to me. If you can't get it, you can also let me know. Then yeah, the integral, it was cos, you can just copy it down. Is cos is 3x, ne?
Yeah, it's 2x. 2x.
3x sine 2x.
Yeah.
Is dx. Yes, you can copy it and try it.
Okay, I'm done.
Then it's gonna be like a homework.
Very long one.
Yeah, it's a long one. It's not really long. You will find it, you will get it very simple. So that's the one. So I think with an integral, the other one we're going to do, if we are having integral class tomorrow, we are going to do, it's going to be the last one about the integral. We are going to work with the integral of maybe arctan, like this way, dx, this kind of integral. Then we're gonna be done with our integral.
Oh, okay.
Done integral by part. We're also gonna maybe touch a partial integrals, but I'm gonna check this. I will have to go through the question paper of your modules to check how far you go with the integrals. Then we're gonna take it from there.
Okay.
So I'm not gonna finish that one, it's fine. Then I'm gonna even send you the